Let's review the different forms of linear functions. We'll talk about slope-intercept form, standard form, and point-slope form. We'll start with the slope-intercept form of a line. This particular equation is a linear function because we have an x and a y where the x is to the first power. It is in the form y equals mx plus b, where b is the y-intercept. That is the point where the line crosses through the y-axis. In this case, the y-intercept is 1. M is the slope, which is the measure of the steepness of a line. We think about slope as rise over run. In this case, our slope is -2, which can be thought of as -2 over 1. So from my y-intercept, let's drop down 2 and to the right 1. And we'll continue that pattern. We can also go up 2 and to the left 1. So now what we're going to do is connect these points with a straight line. And this is our linear function. This is the graph of the linear function, whose equation is y equals -2x plus 1. Again, that's slope-intercept form. Now, sometimes you'll be given the graph of a line, and you'll be asked to write its equation, this time in slope-intercept form. So, of course, we need the intercept. The y-intercept is -1, and the slope can be measured by looking at a slope triangle from point to point. If we go up 2 and to the right 3, we understand that this slope is positive because as we read from left to right, the line is rising, so the slope is 2/3. So the equation of the line is y equals 2/3 x minus 1 in slope-intercept form. Now let's look at another form of a line called the standard form. That's when a line is in the form ax plus by equals c. Very often to graph this line, students automatically want to rewrite it in slope-intercept form and go from there. Now while you can do that, I want you to notice that the coefficients of x and y happen to be compatible numbers with that constant term of -12. So we could make just a table of values and use intercepts to graph this line. So if x is 0, look back up at the equation, we'd end up with 3y equals -12, so y would equal -4. If y were equal to 0, -2x equals -12, x would equal 6. So here we have two ordered pairs that we could use to graph the line. We'll start at 0, -4, and then we'll graph 6, 0. And we'll connect these points with a straight line. Here is our line, -2x plus 3y equals -12. That was again given in standard form. ax plus by equals c. Here is a line, and we're asked to write the equation in standard form, which looks like this. In this case, you might use the y-intercept and the slope. Write this line in slope-intercept form and go from there to write it in standard form. So that's what we're going to do. We'll look at the y-intercept, which is 2. The slope is -2/3. Negative because as you read from left to right, the line is falling. So in slope-intercept form, we have -2/3 x plus 2. And what we can do is manipulate this equation using algebraic techniques to write it in standard form. So let's first multiply every term in this equation by 3. That will get rid of the denominator in the fraction there. So it'll be 3y equals -2x plus 6. Now add 2x to both sides, and here's our standard form equation. 2x plus 3y equals 6. Okay, we have one more form of a line to look at. And here, this particular equation is given in point-slope form, which you'll recall is y minus y sub 1 equals m times x minus x sub 1, where x1, y1 is a point that lies on this line. And so we can identify the point right off of the equation. M is the slope of the line. Again, rise over run. In this case, M is negative, so I expect my line to be falling. All right, so let's first take a look at a point that lies on the line. Well, the x1, y1 would be 1, 3. So we can graph that point, easy enough. And we can use the slope of -2 and drop down 2 into the right one, or up 2 into the left one. And here's our line. Y minus 3 equals -2 times the quantity x minus 1. I graphed it right from point-slope form of the line. If in fact somebody were to ask me, what is this equation in slope-intercept form, I don't need to manipulate the equation algebraically. I can just look at my graph and I get y equals -2x plus 5. One last example will give you the graph of a line. You can see that there is a point that is obvious. We can determine the slope, and we can go from there. Here's our formula that we'll be using. Y minus y sub 1 equals m times x minus x sub 1. All right, so the point that we can identify is located at -2, 1. And I can see there is another lattice point right there on the x-axis. So that enables me to measure the slope. Rise over run, which will be -1/3. Now I have enough information to substitute these quantities into the equation. So we'll have y minus 1 equals -1/3 times x minus -2. Be very careful there with the double negatives, so we will often want to rewrite this in a better way. In point-slope form, it would be y minus 1 equals -1/3 times x plus 2.